Hi. So today in this video, we'll be solving engineering mechanics 2 marks question from question number 41 to 50. So let us start. Okay, this question number 41. Yes, I'm sorry, the question is little bit incomplete. So this force is actually 2000 Newton. 2000 Newton, not 200 Newton, 2000 Newton. Okay, the figure below shown a pair of pin joint gripped together gripper tongs holding an object of 2000 Newton. Okay, the coefficient of friction at the gripping surface is 0.1. Full stop. Axis is the line of action of the input force. So this is the line of action of the input force. YY is the line of application of the gripping force. YY is the line of application of the gripping force. If the pin joint is assumed to be frictionless, okay, the pin joint is frictionless, the magnitude of force F required to hold the weight is. The magnitude of force F required to hold the weight is. Okay, so definitely the weight is being held because of the frictional force produced here, right? So there will be two frictional force on both the sides, right? So this frictional force is because of the normal reaction that will be produced here at the tongs. This frictional force will be because of the normal reaction that is produced of the tongs, right? So if I want to consider, so let me consider the FBD of one of the tongue, right? Let me consider the FBD of one of the tongue, right? And let me consider the FBD of one of the tongue. So this is the force F. This is the normal reaction N. So can I calculate the normal reaction N? Can I calculate the normal reaction N? Yes or no? Can I calculate the normal reaction N? Right? If I take moment, summation of moment about point O should be equal to 0. Right? So I can say force F multiplied by, this implies force F multiplied by 300. 300 should be is equal to the normal reaction N multiplied by 150. So this implies you can clearly see the normal reaction is actually 2 times the force. Normal reaction is 2 times the force, right? So now what is the friction force? Friction force Fs for limiting condition Fs max 2 mu into n, right? So that is equal to mu into 2 of F, right? So now friction force will be on both the sides. So how much is one friction force L? So can I say 2000 divided by 2 is equal to mu. What is the value of mu? Mu is 0.1 into 2 into F. So this implies F is equal to, what is F now? F will come out to be 2000 divided by 0.1, that is 20,000, divided by 4, that is coming out to be 5,000 Newton. 5,000 Newton. Okay. This question, the answer is definitely 5,000 Newton, but there is some problem in this solution. There is some problem in this solution. I'll tell you there is some problem in this FBD. So if you are able to point out what is the problem is, I've given you the answer, but there is some problem with the FBD. If you can bring out the problem, right? Tell me in the comment section. Okay, let us move on to the next question. That is question number 42. A, B and CD are two uniform identical bars of 10 kg each as shown. The hinges at A and B are frictionless. Okay, there is no friction. The assembly is released from rest and the motion occurs in the vertical plane. At the instant that the hinge B passes through the point B, at the instant the hinge B passes through the point B, the angle between the two bars will be. Okay, very simple question. So what is the question exactly? Let me tell you. Okay, what is the question exactly? Let me tell you. So you can see this image, right? You can see this image. So this is This is the rod, the horizontal rod, right? So initially it was in this position, then it was left. So it will come down here. Right? It will come down here like this. Right? So when it has come down here like this, so what will be the angle of the member CD with the vertical? Angle between the two bars. So what is the angle between the two bars? So what is the angle between two bars? Now you can say this is the angle between two bars, or you can say this is the angle between two bars, whatever the angle might be, right? At the instant when the horizontal rod passes through point B, right? At this position, what is the angle between two bars? Okay, so what concept to be applied here? If you look at the member CD, if you look at the member CD, if you look at the member CD, let me say this is the member CD. So what are the different forces acting on the member CD? The different forces acting on member CD are the weight W. It is frictionless. There might be some normal reaction. Okay, normal reaction N. So W and N both are passing through the center of the member CD. So if I take a torque, if I take a moment about point O, B, that is the center. If I take the moment about point B, so what is the moment about point B? Can I say moment about point B is 0 for this member CD? For the member CD, the moment about point B is 0. Why? Because both the forces, normal reaction and W, are passing through the center. Is there any other force? No. Right? So if the moment about point B is 0, can I say the rotation about point B will be null? There is no moment. So the member CD will actually not rotate. The member CD will not rotate. Why? Because the net torque is 0 or that moment is 0. So if it is not going to rotate, so the member CD will maintain its inclination if it is pointing towards northeast. If it is 45 degree to the vertical, so it will maintain its angle, maintain its orientation, right? So are you able to imagine that if this is the member CD at this point of time, it is not going to change its angle. Its angle will remain like this. Right? It has not rotated. Only the black color, that is a horizontal member, has become vertical, but this member has not rotated. So now can you comment on the angle? Can you see that this angle will be equal? This angle and this angle will be equal, right? So this angle, okay, यहाँ पर थोड़ा सा क्वेश्चन में गलती है, ये क्वेश्चन दिया होना चाहिए. This angle is actually 30 degree. This will be given in the question. This angle is actually 30 degree. Theta is equal to 30 degree. Theta is equal to 30 degree. If that is the case, so what is the answer? Here also theta is equal to 30 degree. Answer is C. Okay, so a slight correction. Okay, I'll correct it in the PDF. And this angle should be given, this angle theta, it is given in the equation. It is given in the equation that this theta is equal to 30 degree. Right? I hope it is clear. I hope it is clear to all of you. So let us move on to the next question. Okay, 43. Very amazing question. Two smooth identical spheres, each of radius 125 mm and weight 100 Newton, rest in the horizontal channel having vertical walls. The distance between the vertical walls of the channel is 400 mm. The reaction at the point of contact between the two spheres is. The reaction at the point of contact between the two spheres is dash Newton. Okay, so let me try to draw the FBD of the upper sphere. So what are the different forces acting on this? Can I say there is a weight W, reaction N1, and a reaction N2. So what am I required to find out? I am required to find out N1. Right? Can I rearrange these forces a little bit? Can I rearrange these forces a little bit? Can I rearrange these forces in this way? Tell me yes or no. W N1. Without changing the direction, definitely I can shift the forces a little bit. N2. Now I think you'll be able to understand why I have done this. I can use Lami's theorem here. So this angle is 90 degree, you can see. One is horizontal, this is vertical. The angle will be 90 degree. Nah? And 2 will be horizontal, nah? Perpendicular to this surface, and this will be vertical. Angle will be 90 degree, undoubtedly. Right? Can we predict other angles? Can we predict other angles? If somehow we can predict this angle, अगर ये एंगल कहीं से पता लग जाता है, this angle, because I need to find out n1, no? I just need to find out n1. So if I can find out this angle, let me say this angle is theta. Theta. Basically, the equation that I can write is n1 sine theta is equal to w. Right? From here I can write n1 is equal to w by sine theta. So the value of w is already given, isn't it? 100 Newton. So if I can somehow find out this angle theta, my task will be done. So let me see if the diagram is given, can I actually find out that angle? Do I know this distance? Yes, this sum of the radius of the two spheres, 125 plus 125. So I can say this is equal to 250. Right? Now, can I know this distance? Again, the total distance is given as 400. From this side to this side, this is 125. From this side to this side is 125. So what will be the middle portion? 400 minus 125 minus 125, 400 minus 250, it is equal to 150. I hope you are able to understand 150. So if I know this two, I don't require anything else. I don't require anything else. Right? I can definitely find out angle theta. In fact, I can find out what is sine of theta. What is cos of theta now? Cos theta is equal to base by hypotenuse. So this is equal to 3 by 5. So what is sine of theta? Sine theta is equal to 1 minus cos theta whole square. So I'm directly writing it as root over 1 minus 3 by 5 whole square. So this is equal to 4 by 5. This is equal to 4 by 5, right? So I can substitute the value. N1 is equal to W is 100 divided by 4 by 5. So what is the value of N1? N1 is equal to 125. See, such an amazing question it is. Beautiful. Solve करके मजा आया. When you solve this kind of questions, you get such a pleasure. This is the pleasure of solving this kind of questions. Okay, let us move on to the next question. 44. Fantastic question. Fantastic question. Fantastic question. Yes, I need to apologize. I was not able to do it at one time. Right? So if this question would have come in GATE and I was appearing that GATE, मेरे से तो नहीं होता. Right? So this question comes in the category of the last. I would have attempted, but this is a numerical answer type question. I would have definitely made mistake. I would have definitely made mistake in answering this question. Okay? So let me be optimistic. I would have made it correct. Okay, I would have done it. Okay, the wheels and axle system lying on a rough surface shown in the figure. Each wheel has a diameter of 0.8, okay, and mass 1 kg. So diameter of the wheel. Let me use a black color pen. So diameter of the wheel is equal to 0.8. So I can say radius of the wheel is equal to 0.4. Mass of wheel is equal to 1 kg. Right? Assume that the mass of the wheel is concentrated in a ring. So I have to assume this as a ring. What else? If the mass of the wheel is concentrated in a rim, so it means it is kind of a ring. So basically, my moment of inertia formula will become easy. Mr square. Okay. The diameter of the axle is 0.2. So diameter of axle is equal to 0.2. So radius of the axle is equal to 0.1. बढ़िया है. So if you want to see it here, this is the radius of the axle. This is the axle. This is the axle. So basically radius of this axle is 0.1. Radius of the entire wheel is 0.4. This is 0.4. Okay. And mass of his axle is 1.5 kg. Mass of axle is equal to 1.5 kg. So what is the total mass? So the mass total empty, if I say there are two wheels, so 2 into 1 kg plus 1.5 kg, right? So it is 3.5 kg, right? The total mass will be there are two wheels and one axle, so 2 into 1 plus 1.5, that is 3.5 kg. Okay. Neglect the moment of inertia of the axle. Neglect the moment of inertia of the axle. Now, why is the moment of inertia you are asked to neglect? Because in comparison to the diameter of the wheel, that is 0.4, the diameter of the axle is very small, right? So basically, you can neglect it, and I have assumed all the mass to be at um, because Excel you will not be able to assume the mass to be at the rim, right? So they have asked us to neglect, but there is a very important twist here. बहुत ही अच्छा twist है, and this is where I got caught up actually. This is where I was unable to solve it. So हम देखेंगे ये चीज क्या है exactly, ठीक है? An effort of 10 Newton you can see is applied on the axle in the horizontal direction shown in the midspan of the axle. Assume that the wheels move on the horizontal surface without slip. There is no slipping, so this is pure rolling. The acceleration of the wheel axle system in horizontal direction. So basically, the system is accelerating with some acceleration A. Let me say ACM. So you are required to find out the ACM. ठीक है? तो एक बार देखते हैं थोड़ा सा क्वेश्चन. इफ यू ट्राई टू विजुअलाइज इतना इजीली नहीं होता है. सो आई विल नॉट सजेस्ट यू टू विजुअलाइज दिस क्वेश्चन. ठीक है, आई नॉट सजेस्ट टू विजुअलाइज दिस क्वेश्चन बिकॉज नहीं होता है, विजुअलाइजेशन नहीं होता है इस क्वेश्चन. एटलीस्ट आई वाज नॉट एबल टू विजुअलाइज इट प्रॉपर्ली. ओके, कोई बात नहीं. इवन विदाउट विजुअलाइजेशन, इफ योर concepts are good, you'll be able to do it. So the 10 Newton force towards right. What else? अरे बोलो बोलो. What else? Is the weight. Normal reaction and a friction. Friction, and the whole system is actually accelerating. This is the center of mass. The whole system is accelerating ACM. Acceleration of center. Okay, fine. Now, if you please place a close attention how to find out the acceleration of center of mass in rolling. Once we have discussed similar kind of question we have discussed. So I know that ACM can be written as alpha into R of the wheel in this case, right? R of the wheel, that is 0.4. So if I can find out alpha somehow, I'll be able to find out the acceleration of center of mass. So how to find out alpha? To find out alpha, definitely I have to use this equation torque is equal to I alpha. Torque is equal to I alpha. Okay, great. I'll use this equation, torque is equal to I alpha. Let me copy this figure. Now, all of you please pay attention here. All of you please pay attention here. Torque is equal to I alpha. About which point should I take the torque? Should I take this torque about the center of mass? If I take the torque about center of mass, there will be unnecessary friction, which we'll have to find out. So better to find out, take the torque of the system about the instantaneous center of rotation. I prefer to take the torque about instantaneous center of rotation. And there is a very good twist here, right? When you're taking the torque about center of ICOR. So the torque about ICOR is equal to moment of inertia about ICOR into alpha. There is one alpha. ऐसा कुछ नहीं होता कि alpha for center of mass is different, alpha for ICOR is different. There is only one alpha for the system. So alpha will be constant throughout. ठीक है, कोई problem नहीं. So the torque, if you now calculate what will be the torque, can I say the torque is nothing else but 10 into, what is this distance? Can I say this distance? This distance is nothing else but radius of the wheel minus radius of the axle. Radius of the wheel minus radial of the axle, this distance, right? So radius of the wheel minus radius of the axle, so this is the torque, net torque, is equal to moment of inertia about the instantaneous center of rotation. So here lies the weight. So now if you take for the rim, or say the wheel, so moment of inertia of the ring about center of mass is mr square. About ICOR is mr square plus mr square, that is 2 mr square. So 2 mass of wheel, radius of wheel square. I hope you got it. नहीं है तो एक बार दिखा देते हैं, कोई प्रॉब्लम नहीं है. This is a ring. So what is the moment of inertia I of ring about the center is equal to mr square. I of ring about the ICOR, instantaneous center of rotation. I of the ring about ICOR. So I can use parallel axis theorem, mr square, that is moment of inertia about the center of mass, plus mr square if this distance is r. This is something basic. Okay, this is something basic. You have to know it, right? So this is equal to 2 mr square. So there are two wheels on both the sides. So this will be 2 mr square plus 2 mr square. Yes or no? 2 mr square plus 2 mr square. Right? Now, here comes the fantastic concept. Now, if you're considering about the center of mass, if you're considering the moment of inertia of the center of mass, is clearly given in the equation, neglect the moment of inertia of the axle. But if you are considering the moment of inertia of about the ICOR, you cannot neglect the moment of inertia of the axle. Now, why it is asked to be neglected? Because the diameter of the axle is small compared to the diameter of the wheel. So if you are considering the moment of inertia about center of mass, definitely you can neglect it. But if you're not considering this about center of mass, so I will take this about ICOR. So now you will not be able to neglect this moment of inertia. Instead, moment of inertia of the axle. So I'll assume this to be a point mass situated at the center. So what will be the moment of inertia of the axle about ICOR? I can simply write it as mass of the axle into r square. Right. So I'll assume the whole mass of the axle concentrated at the center, and it is rotating about ICOR. So mr square, simply mr square. Okay. So into alpha. So let us substitute the values fast. 10 into 0.4 minus 0.1 is equal to 2 into 1 into 0.4 whole square. So plus 2 into 1 into 0.4 whole square plus what is mass of the axle? Mass of the axle is, what is the mass of the axle? Mass of the axle is given, mass of the axle is given as 1.5, and again the radius, I'm going to take the radius of the wheel into 1.5 into 0.4 whole square into. So what is the value of alpha? Let me now calculate what the value of alpha. Interesting सा equation है. 10 into 0.3, 2 into 0.4 square plus 2 into 0.4 square plus 1.5 into 0.4 square. So it is coming out to be 3.409 radian per second square. So if you have the value of alpha, so what now I can find out ACM. ACM is equal to alpha into R of the wheel, that is equal to multiplied by 0.4 is coming out to be 1.3636. 1.3636 meter per second square. So yes, initially I had missed this portion, so I was not getting the answer. I had missed this portion, then I gave it a thought. I was thinking, and suddenly it clicked. I cannot ignore the moment of inertia of the axle about IC. So I have to do this. Okay, so if you have any problem, if you think there are other ways to this, okay, you can comment on the comment section. We can have a discussion. So let us move on to the next question. Question number 45. A plane truss PQRS, PQ is equal to RS, and angle PQR is equal to 90 degrees shown in the figure. The forces in the member PR and RS respectively are. So this is again a very easy question. ठीक है, बहुत easy question है. ठीक है, again truss के questions maximum easy आ रहे हैं. So if you see this corner joint, ठीक है, the first concept that needs to be used here is if two members are meeting at a corner, only two members, and there are no other loads. If two members are meeting at a corner, it is not necessary to be 90 degree, it can be any angle. It can be any angle. If two members are meeting at a corner and there are no other force, no other reaction at that corner point, at that corner joint, then force in both the members will be zero. Force in both the members will be zero. Force in both the members will be equal to zero. Right? You can explain it to yourself why it is happening. Take a force in both the members will be equal to zero. So what is the force in this member? Zero. Force in this member is zero. So it is reduced to a triangle. It is reduced to a triangle, right? Let me draw the triangle. Okay, ठीक है, triangle draw करने से पहले let me say now what will be the direction of forces? You should be able to understand this. The direction of forces, there are only one possible direction of force. The member PR will be under tension and member RS will be under compression. So direction of forces will be this. Again, this is something very interesting. There is no other possibility. No other possibility. You try to reverse it and see this, because the joint R has to be in equilibrium. Any other combination of forces is not possible. This is not possible. This is not possible. If you see, the net forces will be towards right. The net force is towards right. This is not possible, right? So only combination that is possible is this. Only combination possible is this, right? So a shortcut trick, if member PR is pulling the joint, the member itself is under tension. If member RS is pushing the joint, the member itself is under compression. You can remember this. Now, I can actually rearrange the forces little bit for my benefit, because I have to calculate both the forces. Okay, I have just represented it instead of below F RS, I have represented it this way, and let this force be like this, FRP or PR. Okay. Can I calculate the angles? Can I calculate these angles? Now this is 45, this is 45, so this is 45. So most of the angles are 45. So this is clearly, you can see 90 degree, and this will be 90 plus 135, 135. This will be 135 because of symmetry. This will be 135. Right? So I can use Lemon's theorem. I can say FPR divided by sine of 90 is equal to FRS divided by sine of 135 is equal to F divided by sine of 135. Right? So what is FPR now? FPR will become sine root 2F. Sine 135 will be sine of 45. So 1 by root 2. So it will become root 2F. And FRS, you can see sine 135 will get cancelled out. So it is equal to F. The nature of force I have already predicted. PR will be tensile. So PR is tensile. So very basic formula. If a member is pulling a joint, the member itself is under tension. If a member is pushing a joint, the member itself is under compression. You can physically feel, if you're pushing the wall, the kind of force that will be in your hand is compression. If you're pulling a rope, the kind of force that you're you'll experience in your hand is the rope is also pull your hand, right? Tension. Very simple to remember. So this is compression. Okay, I hope it is clear. So what will be the answer? PR, F root 2 tensile, and RS is F compressive. So answer is A. Answer is A. I hope it is clear. Let us move on to next question. Okay, question number 46. Fantastic question. Let us try to solve it. So a block of negligible mass rests on a surface that is inclined at 30 degrees to the horizontal plane as shown in the figure. When a vertical force of 900 Newton and a horizontal force of 750 Newton are applied, the block is just about to slide. The coefficient of static friction. So this is again a case of limiting friction. So if it is a case of limiting friction, I don't know in which direction the block will slide. Uh, no problem with that. Let me say this is the normal reaction. Let me assume it to be in this direction, because this 900 Newton is greater force, so I think it will go slide in the downward direction. Even if you have taken the direction of friction wrong, your answer will come out to be negative. So you need not worry about that. Okay. So this is the case, right? So while drawing the FBD, I'll do a little bit of change. Okay. I'll simply change the direction of change the force little bit for my convenience. So this is the normal reaction N. This is the friction force F, right? And then you have the 750 Newton in this direction, and 900 Newton. I'm just bringing it down, right? The direction is same, just bringing it down because it will be a little bit easier for me to resolve. What I'm going to do is I'll resolve the forces in this two plane, because I need to find out the coefficient of friction. So coefficient of friction, I can directly say F divided by N is nothing else but coefficient of friction. So I want to write down the equation in terms of coefficient of friction. So I'll resolve 900 Newton force, and let me first again see the angles. Let me find out the angles. ठीक है, angles लिख लेते हैं, नहीं तो confuse हो जाएंगे आप. Okay, so this angle is 30 degree. So I can clearly see that this is 30 degree. So this angle is 30. Right. So this is 60. This is 30. Right. Right. So yes, okay, fine, great. Now I can write down the forces. I can resolve the forces. So I can resolve the 900 Newton into two parts. This is 900 cos 30, and this is 900 sin 30. 900 sin 30. Right. Similarly, I can resolve the 750 force also. If I resolve the 750 force, so this will become, sorry, so this will become 750 sine of 30. Actually, the battery in my iPad is very low, so that's why. Okay, ये क्या हो गया? I think I'll stop it now. Okay, the battery in my iPad is low, so it's only 3%. Let me see if I can complete question number 50. Okay, so this becomes 750. This is how much? This is 750 cos of 30, right? तो थोड़ा सा, हाँ, नंबर ऑफ फोर्सेस ज़्यादा है, तो थोड़ा सा आप इस तरह से आप देख सकते हैं. Okay, so what will be the value of F now? Can I say F is equal to 900 sin 30 minus 750 cos of 30. So what is the value of F? 900 sin 30 minus 750 cos of 30 coming out to be 199. Okay, it's coming out to be minus 199.51 minus 199.51. So minus means actually the direction of friction is actually the block has a tendency to move up. So the direction of friction is downwards. कोई problem नहीं, this will not affect the value of our mu. Similarly, what is the n value of n? N is equal to, I can say 900 cos 30 plus 750 sine 30. So the value of n is coming out to be 900 cos 30 plus 750 sine 30. This is equal to 1154.42. 1154.42. 1154.4 Newton. So I'm taking only the magnitude. So what will be the value of mu? Mu is equal to frictional force divided by n. So it is 199.51 divided by 1154.42. It is coming out to be 0.1728. So two decimal places. So two decimal places means 0.17. Easy question, only that you have to draw the FBT, resolve the forces, and very simple concept. Okay. iPad battery is 2%. Let us try to move it fast. Question number 47. Very, very simple question. So you have to find out the number of members in which the forces are zero. Okay. So very easy. We have done similar kind of questions. Okay. When the concept that needs to be used here is when three members are meeting at a joint, and two of them are collinear, like this one and this one, two of them are collinear, the force in the third member is zero. The force in the third member is zero. This is one of the concept that we are going to use. ठीक है, देखते हैं. So let us try to solve. We can clearly see that is applicable at joint B, joint Z, joint D, right? So this is equal to 0, this is equal to 0, this is equal to 0. Clearly all these three are 0. So option B to हट गया. And rest A, C, D all has this 3 0. Now whenever you get this kind of question, right, be a little bit cautious. Means I can easily mark option D as the answer. I can easily mark option D as the answer because BF, DH and GC, BF, GC, DH, these are 0. So it is very easy for me to mark the answer. But when there are 1, 2 options, just try to be cautious, try to see if there could be more members where the force is 0. So if you see this angle is 45, why? I'll not tell you that. See closely, right? This is an isosceles triangle, right? Isosceles triangle. So this angle is 45. This angle is 45. So can I say this R inline? So can I say the reaction force? The reaction force, this reaction will be equal to force in HE. Can I say the reaction force is equal to force in HE? So these two will cancel each other. If these two forces are cancelling each other, because they are collinear, right? So what will be the force in member DE? Can I say the force in member DE will be 0? Because there cannot be any other force, right? Because the joint E has to be in equilibrium. R is equal to F HE. They are cancelling each other, so there cannot be any force in the member D. Otherwise, the joint E will not be in equilibrium. So if D is 0, this is also 0. So what is the correct option now? And I can clearly see the correct option is, we let DE and CD. Option is C. Right. So analysis, you can solve this question through analysis. Very beautiful question. Very, very beautiful question. Okay, this is a very fantastic question. Question number 48. This is a very fantastic question. A 2 kg block shown in the figure rests on a smooth horizontal surface and is attached to a massless elastic cord and has a system stiffness of 5 Newton per meter. So cord, you can say elastic cord, it is behaving like a spring. The only thing difference with the spring is that spring can compress and will apply force. The cord cannot compress, right? The cord can only extend. So this is the only difference, right? So the cord is hinged at O, initially unstressed, okay, and always remains elastic, fantastic. The block is given a velocity of 1.5 meter per second perpendicular to the cord, okay. And the magnitude of velocity in meter per second of the block at the instant a chord is stretched by 0.54 meter is. So what concept we can use here is, now the chord is getting elongated, it is getting stretched. So if it is getting stretched, there must be some amount of strain potential energy, right? Strain energy stored in the chord. So where is this strain energy coming from? I am not supplying the strain energy, you are not supplying the strain energy. So where is the strain energy coming from? It is by conservation of energy. I can say the kinetic energy of the block is getting converted into the strain energy, right? So if I want to say the strain energy, I can write it as half kx square. So this is not coming from anywhere else but from the mechanical energy. So what is the mechanical energy now? What is the mechanical energy? Mechanical energy I can say, oh sorry, kinetic energy half m v1 square. This was the initial kinetic energy minus half m v2 square. So this is the final kinetic energy. So difference in the kinetic energy is nothing else. It has been stored in the chord as the chord potential energy, as the strain energy. So half cancel ho jayega. Let us try to find out. K is 0.5, x is 0.4 whole square. Sorry, not 0.5. K is given as 5 Newton per meter. Sorry, 5 0.4 whole square is equal to mass is 2, v1 is 1.5 whole square minus v2 is what we require to find out. Let us calculate v2 from here. Now there is a twist, थोड़ा सा ट्रिक है क्वेश्चन में, देखते हैं. 5 into 0.4 whole square divided by 2, 1.5 square minus of answer, 5 into 0.4 whole square divided by 2, 1.5 whole square minus of answer, v2 answer. So 1.36. So what is the value of v2? v2 is equal to 1.36 meter per second. So answer is E. So here there is a simple twist. What is the twist? Not twist exactly. So students might actually get confused here. We might actually try to draw the apogee of the block and say the force by this elastic rod, that is kx, should be equal to the centrifugal force. No, we cannot do that because we don't know if when the elastic cord has stretched by a distance of 0.4, is it in equilibrium. It might not be in equilibrium. It can stretch even further, right? The stretch, it can stretch to 0.5, 0.6. I don't know when it is going to come to equilibrium. So I cannot say the block is in equilibrium. So I cannot equate kx to mv square by r, right? No, I cannot do that, right? Many of you will have the tendency at GATE, they have done it so beautifully. This is not a numerical answered equation. They have given you the options. So if you apply that concept, you'll get to know that you have done something wrong, right? Then you'll rethink and then actually come up with the same answer. Same happened to me also. Okay, let us go on to the next question. Okay, question number 49. This is a very nice question. A truss shown in the figure has 4 members of length L and flexural rigidity EI, and 1 member of length L root 2 and flexural rigidity 4 EI. The truss is loaded by a pair of forces of magnitude P as shown in the figure. The smallest value of P for which any of the truss members will buckle is. So basically this is a question which is combination of truss and strength of materials. We'll borrow concept from the columns, chapter of columns from strength of materials. Before that, let us try to understand what will be the forces in each member. So you must be able to realize that if this is force P, I can actually resolve it into P cos 45 and P sine 45 in both the directions, right? So both of them are P by root 2. So I can easily say the force in this member is P by root 2 and force in this member is also P by root 2. Similarly, force in this member is P by root 2 and force in this member is also P by root 2, right? So now P by root 2, P by root 2, what is the force in the diagonal? I can simply say the force in the diagonal will be root over P by root 2 whole square plus P by root 2 whole square. That will come out to be P, right? So force on the sides is P by root 2 and force on the diagonal is P. Okay, so this is, I can make it out from preliminary uh, analysis. Okay, now I am going to borrow a concept from the chapter of columns, that is Euler's buckling load. So what is Euler's buckling load? Euler's buckling load, it is given by pi square EI divided by L square. Actually it is N, but since N term, N will also be there, right? But since this all the members are hinged at both the ends, so the value of N will be equal to 1. So I'm writing pi square EI by L square. Now if you want to find out for the diagonal Euler's buckling load, the force P by root 2. Now for the size, let us start with size. So force P by root 2 should be smaller than equal to the Euler's buckling load for the buckling not to happen. So for buckling not to happen, the mean maximum load that can be applied on the sides should be less than root 2 pi square EI by L square. Similarly, this is for the sides. Now if I consider for the diagonal, P should be smaller than equal to pi square 4 EI, because the fractional rigidity is given as 4 EI divided by root 2 L whole square, because the length is also root 2 L. So the force P should be smaller than equal to, you can see it is 2 pi square EI by L square. So this is the maximum load that can be applied without buckling. So which do you think is the lower of the both? Right? I can clearly say that this is the smaller of the both. So if the force P exceeds root 2 pi square EI by L square, the sides will start to buckle. The diagonal won't, but the sides will start to buckle. So what is the minimum load that can be applied at which any of the truss members will buckle? The smallest value of P is the root 2 pi square EI by L square. I hope it is clear. Very simple question, very nice conceptual question, right? Okay, let us move on to the next question. Sorry, this question has not been numbered. This should have been 50. The next question should have been 51. Sorry, I got a call. Okay. Uh, okay, let it be non-numbered. So basically, you have to see the FBD of the diagram. There are two concepts here. There are two concepts here that I'm going to use. Let us try to figure it out. What is the FBD of this problem? First of all, I'll reject this. Why? Because the surrounding is being shown. I cannot show the surrounding in drawing an FBD, right? So option B can't be true. Now you see option C and A. Option C and A. So if you see option C and A, you will be able to predict that these two, option A and C, are not in equilibrium. Option A and C are not in equilibrium, because if you take a moment about the center, because of the friction force, see the direction of friction force are same. So because of the friction force, they will not be in equilibrium. It will be in rotational motion, right? But that is not the case, right? I am drawing the free body diagram of the roller when the roller is just about to climb over the steps. So just about to climb means till now it is still in equilibrium. So definitely option C is also not there. Similarly, I can reject option A also. So finally, I'll get the answer as option D. Finally, I'll get the answer as option D. So this is one way. The second way, I'll tell you, if three forces are acting on a body, if the body is in equilibrium, all the three forces should be concurrent. So you can see if this is the center, right? Three forces F, R, and W are acting on this body. All these three forces should be concurrent. So you can see definitely that way also you can predict that this is the right answer. Okay, simple question. Let us now move on to the next question. Last question, question number 50. A rigid of mass m1 is equal to 10 kg having a velocity v0 is equal to 2 meter per second strikes a stationary block of mass m2 30 after traveling 1 meter along a frictionless horizontal surface as shown in the figure. The two masses stick together and jointly move by a distance of 0.25 further along the same frictionless surface before they touch the massless buffer that is connected to a rigid vertical wall by means of linear spring having a spring constant k 10 to the power k is equal to 10 to the power 5 Newton per meter. The maximum deflection of spring is okay. Simple question, conceptual question, right? First, I will conserve the momentum, right? I can say initial momentum P initial is equal to P final. So what is the P initial? I can say M1 into V naught should be is equal to, after striking, it is clearly seen, say that they stick to each other. So I can say M1 plus M2 into, let me say, V. So what is the velocity? Combined velocity, I can say combined velocity after the collision is. So this first equation is equation of momentum. M1 V naught, what is M1? 10. V naught initial velocity is 2 meter per second divided by M1 plus M2 means 10 plus 30. So the value of V is coming out to be 20 divided by 40, that is equal to 0.5 meter per second. So the combined velocity of M1 and M2 after the collision is 0.5 meter per second. So what is the kinetic energies of the system? Kinetic energy. Now, there is no friction, so this energy will continue as the whole system M1 plus M2 strikes the spring and then starts compressing it. What is going to happen? This kinetic energy will get converted into the spring potential energy. So what will be the maximum deflex of the spring? When all the kinetic energy of the system has been converted into the potential energy, spring potential energy, right? So I can say for maximum deflection, half M1 plus M2 V square. This is the kinetic energy of the M1 plus M2 system. Now this will get converted into half kx square. It will get converted into half kx square. So let me write down the values. Half will get cancelled out. 40 into 0.5 whole square is equal to k. Value of k is given as, I'm sorry for that noise, 10 to the power 5 multiplied by x square. So the value of x you can find out from here. I'll use my calculator to find out the value of x. 40 into 0.5 whole square divided by 10 to the power 5. Sorry, 40 into 0.5 whole square divided by 10 to the power 5. Okay, root over answer. I'm getting the value as 0.01. I'm getting the value as 0.01 meter, right? Answer is asked in centimeters, so x is equal to 1 centimeter. So this is the answer. So simple question, easy question. I hope it is clear to all of you. So this is end to engineering mechanics. I've solved all the questions for you. I hope this is helpful for you. So best wishes all of you. Bye bye. Take care.